Hi everybody. In this video we're going to take a closer look at synthesis and decomposition reactions. We'll be looking both at how to recognize the reactions and also how to predict what the products are going to be. So let's get started with synthesis reactions. One of the key features for recognizing them is that you'll see that there's always going to be only one product. In terms of doing the prediction, a couple key rules that we're going to follow is we're always going to put the metal first, and we're going to be adding subscripts to balance off charges. And that's because each time when we do a synthesis reaction for trying to predict them, we're going to stick to only the ones that are going to be making ionic compounds. So they're always going to have a metal and a non-metal. And if you recall from the unit that we did on naming compounds, when you have an ionic compound, the metal is always first. So let's try an example. Let's do calcium plus oxygen. On the product side of the equation, we just have to combine calcium and oxygen together. Now we're going to put calcium first because it's the metal. Now I'm not sure if those subscripts are correct, so what we're going to do is we're going to do a little T-chart and use that to help us figure out what the subscript should be. Now by looking at the periodic table, I can see that calcium would like to be a 2+ for a charge, and then for oxygen, it's likely to be a 2-. So by doing the T-chart, you can see that what will happen is you just need to have one calcium and one oxygen to balance off the charges. And now, after I have the skeleton structure now set, I'm going to go back in, I'm going to try to balance out the equation. I can see that the oxygens are not balanced, so it'll mean that I'll have to put a 2 in front of the calcium oxide, and that messes up the calciums, and so I'll put a 2 in front of there. So just a quick little review on what we had to do to predict out the products is we first had to figure out which one was the metal. That was calcium. We put that first. Then we did a T-chart to try to figure out if there was any subscripts that had to be added to balance out the charges. And then finally the last stage of working with predicting a reaction was to balance out the equation. Let's take a look at our second example. We can see here that copper is a metal, and so we're going to put that first when we write out our products. So it'll give us CuBr. Now let's do a T-chart so we can see if there's any subscripts that need to be added. Now copper is a metal that has more than one possible charge, and the charge that is being used in this one is going to be +1. For metals that have more than one possible charge, this is something that you would have to be told in the problem. So that would be copper as a +1. And then bromine, we could figure out what that charge is by looking at the periodic table and its position. And we can see that it would want to gain 1 electron, giving it a charge of -1. So with our T-chart, it turns out that we do not need to add any subscripts. And now let's go back up and try to balance out the equation. I'll need to put a 2 out in front of CuBr, so to balance off the bromines, and then I'll put a 2 in front of Cu to balance off the coppers. Now one of the things that's interesting to note about this problem is that a common mistake that students make is they want to take the subscripts that are on the left side of the equation and bring them over to the right side of the equation. You should never do this. The reason why this bromine has a subscript of 2 on the left is because bromine is a diatomic element. So when bromine is not in a compound, it'll pair up with itself, but the subscript for bromine is not figured out related to anything to do with diatomic element. It's figured out from working with what it's paired up with in this compound and by balancing out the charges. So just to reinforce, we never bring over subscripts from the left side of the equation to the right side of the equation. The reason for subscripts is always an individual decision on each side. Now let's switch gears and talk about decomposition reactions. The way you want to recognize these is to look at the reactant side and notice that there is only one reactant, and that's breaking up into smaller pieces. When it comes time to do some predicting, some things that we're going to follow is that we're going to break things down in individual elements, so we're only going for a full decomposition when we do the predicting. And anything that is a diatomic element, we'll have to add a subscript of 2. You'll find this to be a very simple reaction type to work with. So let's look at an example. We have aluminum oxide. We're going to break that down into aluminum plus oxygen. Oxygen is diatomic, so that'll get a subscript of 2. And then we just have to worry about balancing. I can see that I will have to use the least common multiple with the oxygen. So we'll put 2 Al2O3s with 3 oxygens. That means that the aluminum, we have 4 aluminums on the left-hand side and only 1 aluminum on the right. So we'll just put a 4 out in front of the aluminum. Okay, let's try one more example. We have iron 2 oxide here, and that's going to break down into iron plus oxygen. Oxygen's diatomic, so we'll put a 2. And then it's just a matter of balancing. So I'll put a 2 out in front of FeO to balance off the oxygens, and then a 2 in front of Fe to balance off the irons. And that wraps that up. So hopefully you're finding the decomposition reaction to be very simple. All we have to do is just list the elements that are present on the left, and if there's a diatomic element, we get a subscript of 2, but don't forget to balance it before you finish.